video, we're going to review arithmetic in preparation for algebra. So first thing we're going to look at is some sets of numbers. And the first set is what we call the natural numbers. It's also called the counting numbers. These are the first set of numbers that it's most natural for people to learn. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Kind of a defining feature here is you could add 2 of these numbers and get a third number to them. And then we have what we call the whole numbers. And this includes the number 0. 1, 2, 3, 4, 5, 6, 7. So if you think about, like, if you had a small child and you asked them to count things, they would start by counting at 1, not 0. Kind of a defining feature here is that you include this number 0 that you can add to another number and keep that other number. So, and then we have what we call the integers. And those are the whole numbers and their additive inverses. Additive inverse, another way of saying that is just opposites. Additive opposite, right? So you have, -3, -2, -1, 0, 1, 2, 3, and so on. So you got 10, you got -10. Those are integers. And then we have what we call the rational numbers. And a way of kind of defining the rational numbers is something like this. So you go, what's going on there? These notations here, where I tried to list the things, this is a form of the roster method of describing a set. So, in the roster method, you would list all the elements, obviously, in an infinite set. I can't list them all, but, I created a list here so you can see the pattern. This one is what we call set builder notation. And so what we're doing is, instead of trying to list all the numbers in the set, I'm creating some kind of definition for how the set is built. And so let me explain what I have written here. This says a rational number is a number that can be written as a number over a number, so basically a fraction, such that the top number and the bottom numbers are elements of, that's what that symbol means, elements of the integers. So if the top number and the bottom number is an integer, then that would be a rational number. The only other restriction is this bottom number cannot be the number 0. So, you can think of like 5 could be written as 5 over 1, or 10 over 2, or -15 over -3. So, all those are different ways of representing the number 5, so therefore a 5 is a rational number. Up to this point, every previous number, or every new set of numbers includes the previous set of numbers. So all natural numbers are also whole numbers. Now 0 is a whole number but not a natural number, but every other natural number is also a whole number. Every whole number is an integer, though there's integers that aren't whole numbers. Every integer, and therefore every whole number and natural number, are rational numbers, but there are numbers that are not integers or whole numbers or natural numbers. So what kind of numbers are, fractions, like I said, and this is both proper and improper fractions, mixed numbers, 5 2/3. That's a terminating decimals, are rational numbers. So if you have 0.037, this is read 37 hundredths. That's because you can write this as 37 over 100. So any number that stops, any decimal that stops, you just put it over what that place value name is, and you can write it as a fraction. Repeating decimals. So you have something like 0.15 repeating. This can be written as 15/99, or 5/33 if you reduce it. And you can probably watch some videos of how to turn a repeating decimal into a fraction. It's a little harder than doing a terminating decimal, but it can be done. We're not going to get into that. But if it's a repeating decimal, then that's also a rational number. It can also be turned into a fraction. Then we have irrational numbers. And these are non-repeating, non-terminating decimals. So probably the most famous irrational number would be the number pi. There's also a number e. It's 2.7 something. It's called a natural base. Natural base. Pi is often used with circular situations. So pi is the ratio of the circumference to the diameter of a circle. That's what it's defined as. And then there's less exciting ones, square root of 2, cube root of 7, things like that. So there's an infinite number of irrational numbers as well. And then we have what we call the real numbers. And these are the rationals and the irrational, plus the irrationals. You put all those together, and those are the real numbers. Now, that's not all the numbers. There's other numbers beyond that, but in this course, that's as far as we're going to get. And we're not going to get to the irrational numbers till almost the end, and we'll start working with things like square root of 2. Okay, so those are sets of numbers. So let's talk about operations of numbers. So I'm not going to go over operations of whole numbers and natural numbers. I assume that if you watch Sesame Street or something, you kind of understand them. So let's start with integers and adding. Okay, so if I want to add integers, let's say I have 6 plus 4, negative 6 plus negative 4, negative 6 plus positive 4, and positive 6 plus negative 4. I say, okay, what do I get if I do these additions? Well, 6 plus 4, that's 10. I mean, we all know that. Negative 6 and negative 4 is negative 10. Negative 6 and positive 4 is negative 2. And 6 plus negative 4 is positive 2. So this is how adding integers works. Is if the signs are the same, then you just increase more of those. So 6 positives and 4 positives gives you a total of 10 positives. 6 negatives and 4 negatives gives you a total of 10 negatives. On the other hand, if you have different signs, one's positive and one's negative, then what you do is you find out how different these two numbers are. So 6 and 4 are different by 2. And then you take the sign of the larger number. So if the larger number is negative, then your answer is negative. If the larger number is positive, your answer is positive. Basically, these 4 positives cancel out 4 of the negatives, leaving you 2 negatives left over. These 4 negatives cancel out 4 of the positives here, leaving you 2 positives left over. If you ever watch like football or something, you understand. You kind of have an understanding of this. You lose 6 yards, and then on the next play you gain 4 yards. You're still down 2 yards. You gain 6 yards on the first play, and then you lose 4 yards. You're up 2 yards. So whereas if you lose 6 yards, and then you lose 4 yards, now you're down 10 yards. So you kind of have an idea how that works. Subtracting. Subtracting is tricky. So 6 minus 4. Negative 6 minus negative 4, negative 6 minus 4, and positive 6 minus negative 4. All right. So 6 minus 4, 2. We know that. And we're not looking to make easy problems hard. So the 6 minus 4 and the 6 plus 4, we're not trying to overcomplicate that. Now, one thing we need to realize here is there is actually no subtracting. What we're going to do is we're going to add the opposite. We're going to add the opposite. So when I say 6 minus 4, what I really want to think about that is a 6 plus negative 4. We're going to add the opposite of 4. And so you can kind of see, oh, that's just like this problem here. So if I don't subtract, I add the opposite. When I say negative 6 minus negative 4, what I'm really going to do is I'm going to add the opposite of negative 4. So this is really negative 6 plus positive 4. That's negative 2. Here, I'm not going to subtract 4. I'm going to add negative 4. So I have negative 6 and negative 4 making negative 10. And again, here, I'm not going to subtract negative 4. I'm going to add positive 4. It gives me positive 10. So you don't subtract, you add the opposite. Now, like I said, we're not trying to make this overly complicated. So in this first example, I would not have wasted my time doing that. I would just say 6 minus 4 is 2. But thinking of this as an addition, and thinking of this as the sign going with this number, that the 6 is a positive, no sign means it's positive, and the 4 is a negative. The 6 is, so let me, well, not that one. Let's leave that. Anytime you see minus minus, make that a plus plus. Just do it. But let me go over here. So here, I'm going to look at this as 6 negatives and then 4 negatives, give me a total of 10 negatives. Anytime I see minus minus, I'm going to say plus plus. Anytime you see that. So this is 6 negatives and 4 positives. Put those together, you have more negatives than you have positives. And then, again, minus minus plus plus, 6 and 4. It may seem strange that you take away, I'd have to make a longer video to kind of explain why that's the case, but it is. So multiplying, let's say I have 6 times, well, here, let's do this. I want to show you all the different types of multiplication here that you might see. So 6 times 4, negative 6 times negative 4, 6 times negative 4, negative 6 times positive 4. So these all symbols all mean multiplication. This little x here, 6 times 4, we're not going to use very much because we're going to start working with variables, and so we don't want to confuse it with the variable x. So this symbol is going to kind of fall by the wayside for the most part. We'll use the little dot more often. Negative 6 times negative 4 is positive 24. And then you also see when things are in parentheses and something's touching it, that means multiplication as well. So 6 times negative 4 is negative 24. And again, we could be, like in this first one, the 6 is not in parentheses and negative 4 is, or it could be both of them are in parentheses. As long as they're touching, that's the important part. Negative 6, positive 4 is negative 24. So what's the rule? If you're multiplying two numbers and they have the same sign, you multiply those together, you get a positive. Negative times negative, positive. If you're multiplying two numbers together and you have different signs, then the answer is negative. So you kind of think like a negative will turn the positive into a negative. It'll change the sign. So if I start with a negative and you multiply by a negative, I'm going to change the sign, so I'm going to make it a positive. And then let me squeeze in here, dividing. I'm going to stop this video and start a new one, continue on, but dividing, same idea. 24 divided by 4, negative 24 divided by negative 4, what do I want to do? Negative 24 over positive 4, and then negative 4 into negative 24. Okay, so 24 divided by 4, that's 6. Negative 24 divided by negative 4 is also 6. Negative 24 divided by 4 is negative 6. And negative 4, oh, I'm going to make that a positive. Negative 4 into positive 24 is negative 6. So just like with the multiplication, if you're dividing and you have two of the same sign, so two positives make a positive, two negatives also make a positive, But when you have different signs, the answer, you're dividing two things, you get different signs, the answer is going to be negative. So negative 24 divided by a positive 4 is a negative, and negative 4 into a positive 24 is a negative 6. So it's just like the multiplication. So I'm going to stop this video and I'll start another one to continue